Hello, everyone. Jordan from Poison Noises here, trying something a little bit different, something I haven't done before. I have kind of come up with this thing that I've been doing for myself lately in lieu of not really ordering any parts because of the current state of the world right now and how difficult that is. And so I've kind of just been designing a lot of things lately. And the mother of invention when it comes to designing guitar pedals is very true to that. What is it? It's good artists borrow, great artists steal, or however it goes. And so that involves me reading a lot of schematics. And I think I maybe underestimated how much time I actually spend just reading schematics, which is not a bad thing. For me, at the very least, maybe for the people around me, it is. But so much so that I started getting to a point I was like, wow, I wonder how much of this I actually have in my memory. And so I started kind of challenging myself to see if I could take these really famous schematics from circuits that everybody knows and see if I can just recreate them on my computer from memory without looking at anything. And I got really close, if not perfect, on a good number of them, starting with some super simple ones. And it kind of brought this idea. First, the idea in my head was, wow, why don't I try doing that on real time? But I think that would be too stressful of a thing to do on a Instagram or YouTube live or something like that. So I kind of came up with this other thing that I think might be fun for me. And we're going to try it right now. So the idea is I'm going to take these circuits that I think I know so well, and keep in mind anything that I have done here. I've also, after drawing this schematic, I've double checked and make sure I'm not giving you guys any misinformation or anything. But the idea is for me to go over schematics part by part, kind of explain what each component in the circuit does, and hopefully give you guys a better understanding of the way, pedal designing actually works, or how, what are all these magical little mojo components actually doing in here. And I thought it would be cool to start with some super simple ones and kind of work our way up. So today I wanted to go over this guy right here, and this is the Dallas Rangemaster. It is a very famous, if not the most famous, treble booster of all time. Famously used by Brian May from Queen. Used to slam an AC30 with it. That's pretty much how I use it whenever I use it. But it's a really simple circuit. I thought it'd be a good one to start with. I mean, it's got a total of 1, 2, 3, 4, 5, 6, 7, 8 components if you include the potentiometer. That's, I think, a great jumping off point. So this is what I want to do. I want to get into this, like I said, kind of try to find a way to approach this that is easy for everyone who maybe doesn't have kind of the electrical engineering brain that you have to develop when you become a pedal builder, and try to find a way to explain this in a way that makes sense to people. So I would really like to be able to go through this kind of linearly, and almost think of it like regular signal flow, like in a pedal board chain, or whatever you might be doing in audio. But the unfortunate truth of that is that components usually are touching more than one thing, and that means that very rarely is a component only accomplishing one task. I'm going to do my best to try and make it seem just like we're taking a couple of forks in the road and figuring out how we're going there, but without further ado, let's jump into it. So, like I said, the first one we're jumping into is this treble booster. And the first thing we hit, coming from the guitar input, right? That's right here. First thing we hit is this capacitor right here. This is C1. C1 stands for the first capacitor in the circuit, right? And it's actually a really small value for the first capacitor in the circuit. You're gonna hear me talk about this in any other future videos I do also, because this first component is pretty crucial to a couple of things. The first thing it's pretty crucial to is it kind of blocks DC at the input. DC being direct current, measures at 0 hertz. And the idea is by creating a high pass filter, you're kind of only letting alternating current through instead of direct current. Which is really what we want. That can be good for stability. It can be good for noise reduction. There's a whole lot of reasons we want to do that, but it's pretty much something we want to do to a pedal circuit after every time we kind of do something important. Okay, we have some kind of big life moment in the pedal circuit. We want to do that. Okay, we want to add some kind of a capacitor. But what's interesting about this capacitor in particular is, like I said, it's a really small value. It's 5 NF. Now, why do we do that? So aside from just cleaning up the DC like we talked about before, it has a secondary function. What that function is in tandem with R1 here at 470K and 68K at R2. It creates a pretty abrasive high pass filter. Okay, so what is a high pass filter? A high pass filter means that high frequencies are passing, low frequencies are being attenuated or cut, right? So they're becoming quieter. And you can kind of do the math. Maybe I'll put the formula right here so you guys can see the appropriate way to be able to figure it out. But the cutoff point for this, if memory serves, which I'm pretty confident in this one, it's 2.6 kilohertz. Okay, so 2,600 hertz. At that point in the signal, it rolls everything below that off. Okay, and the farther you get from that towards 0 hertz, the quieter it gets. Okay, it's like on a slope. That's the way that works, which is pretty aggressive, but it makes sense to why the treble booster kind of has like that super nasally sound that comes with the territory of a treble booster, right? So that's the first thing that happens. The other thing R1 and R2 are doing is they are creating what we call a bias point for Q1. Now, Q1 is the brain of the whole operation. Okay, this is our transistor, and in this particular version of the Rangemaster, this is a germanium transistor. There's the hot word that everybody wants to hear: germanium. Germanium makes all pedals better, apparently. In this case, I actually do agree. I think that germanium transistors generally sound better in treble boosters, just because they have there's like a certain character to them that's a little I don't know, let's say out of control, maybe not stable. Is what it's got mojo. It's something people generally look for when they're looking at this circuit. But what a bias point really is, and there's a couple of them that we kind of have to hit. It's pretty much making sure the transistor gets the voltage it needs to be able to operate in the way that we want it to. Now, there's the way it is supposed to operate, there is a way that it can operate, and then there's like what way makes it sound the best, right? Those are not always necessarily the same thing between those three when it comes to biasing a transistor. In this case, I think we're mostly looking for stability, maybe a little asymmetry for something interesting. I can't quite remember how it works here. And voltage dividers are, to not go over them too crazy, but the way they work is you essentially have one resistor that's touching ground, and then you have one resistor that's touching your voltage supply. And in this case, our voltage supply is actually -9 volts. Okay, and the reason we do that is because we're saying we have a positive ground. Generally speaking, if you think about electronics, it's usually ground is negative and voltage is positive, right? Like you look at the terminals on a 9-volt battery. This is not the case here, and the reason that is because we are working with a PNP transistor instead of an NPN. PNP means positive, negative, positive. NPN means negative, positive, negative, right? And in this case, most germanium transistors are PNP. If we were using a silicon transistor, it would actually be the other way. So, well, depending on the silicon transistor, I'm sure there's some outliers there, right? But all of that being said, the way the voltage divider works, we connect it to those 2 points and we connect them in the middle. And then the center point between those two resistors, between R1 and R2, gives us a different amount of voltage to feed into our transistor. Okay, I can't quite remember what it is for here. I think it's like it takes away like a single volt. Like we really don't lose a lot from this. I'll put the bias points right up here so you guys can actually see what it is. I don't feel like you lose very much right there though. Okay, so then we're sending our signal into this transistor, right? Finally, we're hitting it. Well, we gotta bias it right here at the emitter too. Okay, so we have our emitter, our base, and our collector, right? Those are the 3 pins of this transistor. It's the 3 pins of most transistors of this type. And we do that by putting R3 right here. Now, R3 is 3.9K, okay, and that creates some resistance between our supply voltage and that pin on our transistor. Now that again creates another bias point. We're talking about how stable we want the transistor to be, and you'll notice in parallel. And I say parallel meaning like think about like how guitar pickups are in parallel, right? It's just a way of wiring them where you take one leg from each side and connect them together, right? Okay, almost kind of like in a loop. And the reason we have C3 here at 47 UF in parallel with this resistor is because it pretty much makes it so no matter the bias point here, we're still getting gain. That's like the best way to explain it. It's kind of it gives us higher gain regardless of R3. It's like almost bypassing it in a way. It's a kind of a difficult thing to explain, but it is crucial to the way that we get gain out of this portion of the pedal, which we refer to as the feedback network. Okay, you'll notice that here it's actually kind of looks like a loop we have going on right here, right? And that is negative feedback, which is like the cornerstone of all dirt and distortion you're gonna find in guitar pedals. We'll get more into that in some later videos probably. Where it's a little bit easier to explain. You think it would be easier with the smaller circuit. I actually find it's easier with a couple of more complicated ones personally. But anyways, so we got that kind of feedback network going on here. And then we're getting to the end of the circuit now, right? So what do we have right here? Right here is what we call a potentiometer. Okay, a potentiometer is what, electrical engineers are call a knob, right? And really what it is it's two variable resistors that change proportionately to each other. Now it's not the actual knob, it is the mechanism the knob is on top of. Okay, but what it is, it's a control. It's something we can manipulate in this circuit and change to get different results from this circuit. So what are we getting from this? Well, we have a lot of gain on tap on this pedal. I believe, if memory serves, I had a lot of these that I knocked out of the park. I'm going to be really embarrassed if I don't get them right this time around. But what we have is like roughly like 38 decibels of gain coming out of this thing, which is a lot. I think like the micro amp isn't even that much. I think that one's like somewhere in the low 20s. I'd have to look that up or look it up yourself. But that's a lot. So we need to be able to control that volume because we don't want that thing just screaming all the way up into the amp. Or maybe you do. Who knows? But what we have here is actually the same configuration for a potentiometer that you would find like in your guitar, like your guitar volume pot. Okay. This you actually almost can think about like a fork in the road, right? Think about like pin 2 here, which is this middle one, kind of leaning more towards one side or the other side of the pot. The little dot here on this one indicates where pin 1 is, and then pin 3 would be connected to our collector on the transistor, which you can almost think about as your output in this case. It's not quite as simple as that, but it's a good way to think about it in this context. So as you turn the pot this way, right, towards the third pin, now we've got a nice path between our signal coming out and going out in this direction. But if you run it the other way, now you're running it towards ground. And generally speaking, when you run a signal towards ground in audio electronics, it makes it quieter. Okay, you're making the signal weaker is literally what you're doing. That being said, after we come out here and we have our stable volume for whatever we want it by, I mean, this for all intents and purposes is actually also a voltage divider, right? If you think about it the same way you thought about it right here, we can just control these two values by turning a knob now. So once we get whatever we want out of that, we hit another capacitor at a small value. And what is this one doing? The exact same thing the first one was doing. We are just cleaning up DC at the output of this potentiometer, okay? And just to give us a nice stable signal coming out into the output. And that's pretty much all there is to. I know that feels like a lot, just kind of, coming at it from someone who doesn't know anything. But yeah, it's simple enough. It's a great design. It works. There's this component over here too, this C4 kind of just removes some, it's like a little bit of noise filtering, but for our power supply. There's like no reverse polarity protection or anything for this because these just ran on batteries. So people weren't really concerned that you were going to plug the wrong power supply into this thing. So this just kind of removes some like hum in the signal. That's pretty much all that does. I kind of want to go over like some mods you could do for this also. But there really isn't too much you could do. You could put a little potentiometer right here and kind of like adjust where you want the where you would want the bias point to be. That might be cool. I'm sure there's some mojo number for where they say like the perfect, number is to bias it there. You can make this value bigger. You can make C1 bigger, and you can actually allow more low end through. Eventually you could just make it would just be like a clean boost. Not quite clean, to be a pretty dirty one, honestly, with that much gain. But you could change that to a bigger value to get more base out of it. You can kind of do the same thing for this one. It wouldn't necessarily be as important as that one to do it with, in my opinion. If you did this with a silicon transistor instead of germanium, something that was NPN, you could pretty much just like flip that capacitor over. And depending on the power of that particular transistor, some other values that have to change also. Add some reverse polarity, like I said before, but like that's really it. Maybe a smoother taper. Maybe this would be better at an audio taper at A10K instead of B10K. You just gotta try stuff. And with circuits this simple, it's pretty easy to try stuff because you just take one thing out, put one thing in. Oh, did that sound good? Nope, it didn't. All right, let's try something else. But that is it, everyone. Thank you so much for jumping in with this. Like I said, I want to do a few of these, and I do plan on it. That being said, let me know, one, if I made any mistakes here. If anyone smarter than me can tell me that I missed something on here, please let me know. But let me know what circuits you guys would like me to go over. I mean, let me know if you just don't like this, you know what I mean? Let me know if you have any questions, just hit up the comments, or message me directly if you're scared to do that. But like, just ask me anything about these, because I think about these things a lot. I spend a lot of time just kind of talking about these to myself mostly, but I would love to talk to some other people about it. And without much else to do, without having any parts available to come to me right now, this is a lot of what I'm doing. So I have the time for it. Thanks so much. Please like and subscribe, do all the YouTubey things. Tell your friends about it, anyone who might be interested in this. And yeah, I will see you guys next time.